Okay, I hope I'm audible to all my students who are attending this particular lecture for the intermediate statistical methods for economics course. In this particular lecture, I'm going to start with the discussion of the 2023 question paper for the intermediate statistical methods for economics course at Delhi University. So let's quickly start with the 2023 question paper discussion in this particular lecture. So let's quickly start with this lecture. So I hope all students can see the question paper on your screens. This is the question paper for the BA Honors Economics course. The name of the paper is Intermediate Statistics for Economics, okay, offered in semester 2 of Delhi University. Okay, so let's quickly look at the discussion of some questions which have come up. So we first look at section 1. Now, from section 1, only 2 questions have to be attempted by students, but I will be solving all problems from section 1. Okay, so let's look at the first question. Let Y denote the number of contracts received by a randomly selected infrastructural company. We are given the probability mass function of Y. We are given that Y takes the values. Y is a random variable denoting number of contracts. It takes the value 1 with probability 0.2. It takes the value 2 with probability 0.4. It takes the value 3 with probability 0.3 and 4 with probability 0.1. The question asks us, consider a random sample of 2 companies. So we are picking 2 such companies. Okay, obtain the probability distribution of the sample variances, S squared. So let's quickly come to the whiteboard and let's solve this particular problem. So I'm just writing the main heading for completeness. We are looking at the Delhi University 2023 question paper for intermediate methods for economics. Okay, so let's look at question number 1. Okay, I am just writing what is given to us. We are given that we're given the probability mass function of Y. So we are just writing it for clarity that Y is the random variable. Y denotes the number of contracts received by a randomly selected infrastructural company. Randomly selected infrastructure company. Okay, and we are given the probability mass function of Y. We are given that Y takes the values 1, 2, 3, and 4, and the probability mass function of Y is it takes the value 1 with probability 0.2, 2 with probability 0.4, it takes the value 3 with probability 0.3, and it takes the value 4 with probability 0.1. Okay, now this is for one company. I have 2 such companies because when I'm taking a sample of 2 companies is taken. A random sample of 2 companies is taken. So what is going to be my possible outcomes? My set of possible outcomes are, so it's like throwing 2 dice. Set of possible outcomes are as follows. I can write them in the form of a set. 1, 1. 1, 1 means the first company also receives 1 contract. The second company also receives 1 contract. Another option is 1, 2. The first company receives 1 contract, but the second company receives 2 contracts. Similarly, 1, 3, 1, 4. 2, 1, 2, 2, 2, 3, 2, 4. 2, 4 would mean that the first company receives 2 contracts, the second company receives 4 contracts. Similarly, I have 3, 1, 3, 2, 3, 3, 3, 4. And then I have 4, 1, 4, 2, 4, 3, 4. Okay, so these are the set of possible outcomes for the two companies. Okay, and I can say that let Y1 denote the number of contracts received by company 1. So Y1 denotes the number of contracts received by. So let me write this clearly. Y1 denotes the number of contracts received by company 1. And Y2 denotes the number of contracts received by company 2. Number of contracts received by company. Okay, so I can now make a table. So we have a whole table now of these values. So I can erase all this off because I will be needing some good amount of space. So I'm going to write all these in the form of a table now. So I have Y1, I have Y2. Okay, possible options are 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4. Again, I think I will be constrained by space. So what I can do is I can erase this part also. So I'm erasing all this off and I'm managing space. I'm making a table here because I need more values. This is Y1, this is Y2. So 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, 4, 2, 4, 3, 4, 4. Okay, these are the values taken by Y1 and Y2. We can now find the probabilities, the joint probabilities of Y1 and Y2. So what is the probability of Y taking the value, Y1 taking the value 1 and Y2 taking the value 1? 0.2 into 0.2, which is so 0.2 times 0.2, which is 0.04. Similarly, probability of Y1 taking the value 1 and Y2 taking the value 2 will be 0.2 into 0.4, which is 0.08. Similarly, 1, 3 would mean 0.2 times 0.3, which is 0.06. 1, 4 would mean 0.2 times 0.1, which is 0.02. Okay. And then we have 2, 1 would mean 0.4 times 0.2, 0.08. 2, 2 would mean 0.4 times 0.4, which is 0.16. 2, 3 would mean 0.4 times 0.3, which is 0.12. 2, 4 would mean 0.4 times 0.1, which is 0.04. 3, 1 would mean 0.3 times 0.2, which is 0.06. 3, 2 would mean 0.3 times 0.4, which is 0.12. 3, 3 would mean 0.3 times 0.3, which is 0.09. 3, 4 means 0.3 times 0.1, which is 0.03. 4, 1 would mean 0.1 times 0.2, which is 0.02. 4, 2 would mean 0.1 times 0.4, which is 0.04. 4, 3 would mean 0.1 times 0.3, which is 0.03. 4, 4 would mean 0.1 times 0.1, which is 0.01. So these are the probabilities which I got from this table. Where suppose randomly, just to revise again, if I just take up, let's say 2 and 4. So what's the probability of y1 taking the value 2 and y2 taking the value 4? 0.4 into 0.1, which is 0.04. So this is just taken to explain. So now I can erase all this off and I can write the final answer. Because remember, we are all constrained with space. So let me write the final answer. And then I'll erase that column. This is 0.04, 0.08. Let me just copy this column again. What I'm just doing is I'm just copying the column to save on space. Okay, and then I erase all this off. So we have got the probabilities. Now to find the sample variance, remember the formula S square is equal to, for the first one, it is summation y1 minus y bar square over how much sample we are taking? We are taking a sample of two companies, right? So over 2 minus 1. In general, it's n minus 1, right? Where n denotes the size of the sample. If I just write the formula, where n denotes the sample size. So this is S1, this is S1 square. And similarly, S2 square will be summation y2 minus y bar square over n minus 1. In both these cases, guys, n is 2. Because we are taking a sample of how many companies? 2 companies. So S1 square will just be summation y1 minus y bar square over 2 minus 1, which is summation y1 minus y bar square. This is my S1 square. And S2 square will be summation y2 minus y bar square over n minus 1 would mean 2 minus 1. So again, my S2 square is summation y2 minus y bar square. And the total sample variance S square will be the sum of the two sample variances, S1 square plus S2 square. That means it's going to be just summation y1 minus y bar square plus summation y2 minus y bar square. Okay, now to calculate that, I need to calculate S square for each of these. So first of all, I need to find y bar. Now what is y bar? Y bar is nothing but y1 plus y2 by 2. Okay, so I'm writing it here. Y bar will just be y1 plus y2 divided by 2. And I have to do this for all observations. So 1 plus 1 divided by 2 would mean 1. 1 plus 2 is 3 divided by 2, 1.5. 1 plus 3, 4 divided by 2, 2. 1 plus 4, 5 divided by 2, 2.5. 2 plus 1, 3 divided by 2, 1.5. 2 plus 2, 4 divided by 2, 2. 2 plus 3, 5 divided by 2, 2.5. 2 plus 4, 6 divided by 2, 3. 3 plus 1, 4 divided by 2, 2. 3 plus 2, 5 divided by 2, 2.5. 3 plus 3, 6 divided by 2, 3. 3 plus 4, 7 divided by 2, 3.5. 4 plus 1, 5 divided by 2, 2.5. 4 plus 2, 6 divided by 2, 3. 4 plus 3, 7 divided by 2, 3.5. 4 plus 4, 8 divided by 2, 4. So this is our y bar. Okay. And now how do I calculate S square? S square is Remember, y1 minus y bar square plus y2 minus y bar square. So it's going to be 1 minus 1 square, 1 minus 1 square plus this 1 minus 1 square, which is 0. Similarly, 1 minus 1.5 square plus 2 minus 1.5 square. Let's find this out. So 1 minus 1.5 is minus 0.5. Minus 0.5 square is 0.2. 0.25, and this is also 0.25. So 0.25 plus 0.25 is 0.5. So I can erase this and I can write that the answer here is 0.25. Then it's going to be 1 minus 2 square plus 3 minus 2 square. So 1 minus 2 is minus 1, squared up 1, 3 minus 2, 1, 1 square is 1, 1 plus 1 is 2. So I can erase this and I can just write 2. Then it's going to be 1 minus 2.5 square plus 4 minus 2.5 square. So students can clearly see that 1 minus 2.5 comes out as minus 1.5, and if you square up, it's 2.25. And 4 minus 2.5 is also 1.5, square up 2.25. So 2.25 squared up, added up, gives me 4.5. So if I erase this off, I get the answer as 4.5. And likewise, students can calculate for others also. If I do 2 comma 1, so again it's going to be 2 minus 1.5 square plus 1 minus 1.5 square. Now again, this is 0.5 square plus 0.5 square, which is 0.5. So if I erase this off, it gives me 0.5. Similarly, 2 minus 2 square plus 2 minus 2 square, 0. Now we can do it orally. 2 minus 2.5 square is 0.25. 3 minus 2.5 square, again 0.25. 0.25 plus 0.25 is 0.5. Similarly, 2 minus 3 square, 1. 4 minus 3 square, 1. 1 plus 1, 2. Similarly, 3 minus 2 square, 1. And 1 minus 2 square, again 1. So this is again 2. 3 minus 2.5 square is 0.25. 2 minus 2.5 square, 0.25. 0.25 plus 0.25, 0.5. And similarly, this will be 0. This will be 3 minus 3.5, which is 0.5 square, 0.25, 0.5. This is 1.5, 2.25 plus 2.25 comes out as 4.5. This is going to be 4 minus 3. This is going to be 2. This is going to be 0.25 as my answer. And this is going to be 0. These are the values we will be getting. So now I can make the probability distribution of S squared. So if I erase this whole part off, erasing this part off, let's now look at the probability distribution of S squared. So what are the values S squared is taking? It takes the value 0, as you can see. And let's also look at the probabilities of S squared. So in total, there are how many observations? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. S is taking the value 0 how many times? 1, 2, and 3, and 4 on the top also. It's taking the value 0 4 times. So my probability is 4 by 16, which comes out as 1 by 4, which is 0.25. Then the next value taken by S square is 0.5, as all students get. It's taking the value 0.5 how many times? 1, 2, 3, 4. It's taking the value 0.5 4 times. So let's double check also once again how many times it's taking the value 0.5. Also a slight error I have made. Let me correct that error. There is no value such as 0.25. This is also 0.5. So please correct this. This is 0.5. Because 1 minus 1.5 square is 0.25 and 2 minus 1.5 square is also 0.25. So wherever students see 0.25, please replace it with 0.5 only. So even this will be 0.5. Even this will be 0.5. So now how many total values is taken by 0.5? 1, 2, 3, 4, 5. So the probability is 5 by 16, which is 0.375. Then let's look at the next value, which is 2. S square is also taking the value 2. How many times? 1, 2, 3, 4. So answer is 4 by 16, which is again 0.25. And then S square is also taking the value 4.5. 4.5 is taken how many times? 1 and 2 times. So 2 by 16, which is 1 by 4, which is 0.125. So my probability distribution is that probability. This is my probability distribution of S square. So I can now calculate. The next part of the question is asking us what? So this is the answer for part A. And part B, if I come back to the question paper, calculate the probability of S square more than 2.7 and S square lying between 1.5 and 7.5. So let's come back to the paper, the whiteboard. Probability of S square more than 2.7 means probability of S square equal to 4.5, because the only value taken by S square more than 2.7 is 4.5. And what is the probability of S square taking the value 4.5? The answer is probability of S square taking the value 4.5 is 0.125. And then the question is also asking us to find the probability of S square lying between 1.5 and 7.5. So this is probability of S square taking the value 2 plus probability of S square taking the value 4.5. Because S square takes two values between 1.5 and 7.9. These values are 2 and 4.5. Probability of S square taking the value 2 is 0.25. Probability of S square taking the value 2 is 0.25. And probability of S square taking the value 4.5 is 0.125. If I add up 0.25 plus 0.125, my answer is 0.375. This is the answer for probability of S square taking the value between 1.5 and 7.9. So with this, we are done completely with question number 1 for discussion. We have found the probability distribution of S square, which is my sample variance. Okay, and we have also calculated the required probabilities as asked by the question. So I stop in this particular lecture. In the next lecture, I'm going to start with the discussion of question 2. So I hope all students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at Divine School of Economics and Mathematics @gmail.com. This is where I stop in this lecture.